All right. Good morning, guys. Today is another study session. Pretty much yesterday I finished with the Visium and I wanted to refactor folder structure just to make it a bit cleaner. But I thought that it would be nice to check other projects before that. So I don't, so I can learn from other more experienced guys, because essentially this is learning and that's the goal. So yeah, I wanted to do this for a while and I think it's time. I asked for some cool open source projects and I found a few that I like. And yeah, I just want to check them out. That's essentially goal for today. If I'll have more time, then I want to read more this page, 100 Go mistakes. And because I tried to read it earlier and it didn't make actually quite sense. Because I needed more experience, and now I feel like I can read about it because I made some mistakes, and now, yeah, it's going to be better for me to understand how to avoid these mistakes and compare nodes, like, for example, concurrency, optimizations, maybe, function methods. Yeah, well, actually everything would be nice to read. But for now, I want to check out project structure. I don't know. I can start up with Go Grafana Loki. Hydra is project that used for authorization, as far as I know. Yeah, I was to know. Or there are tons of recipes from Go Fiber. I found one project yesterday as well. That DDD template. I wanted to check it out as well. So yeah, essentially this is the plan for today. Just checking, reading. I'm gonna be doing 90-minute session today. I don't think that I need too much focus to read all this stuff. So yeah, feel free to ask questions. I'll just put the timer so I know when I need to finish. All right. Warm coffee, amazing. Let's take a look at this stuff. Okay. So we have our main, we are loading config. This actually thing I was looking for. Load 7, what is that? Oh, they have similar function like I do. Run NTX. Well, I guess everyone has. We do the same in JavaScript. How do I do it actually? Yeah, I'm checking recover. So what happens if you get a panic somewhere? Like mine better. Overall, pretty much the same. Generated. This is Swagger. Integration tests. Right, let's look from the inside out product. What do we have in domain? So they're splitting domain. By domain entity, which makes sense. Okay. Do they have value object somewhere? Okay, here probably. Yeah, let's take a look. Errors. How do you use it? Okay. So domain errors. Item. What is item? Okay, let's take a look at the order. Okay. We have order here. Item. Order item. Okay. Okay. This was me playing around, adjusted Postgres. So he's making them unexportable. Product available boolean order. Memory. Let's check out the Postgres version. Okay. Okay. So order domain has orders and products. Okay. I mean order service. Create order. Place product. Okay, I really like this. So he's creating all the stuff within the closure of the function. He provides function into, yeah, this is an interface into here. Right, we are receiving functions, so we're getting order domain here, and then we can do whatever we want, right? We are adding items. We are doing this all in the same transaction. I really like this. Okay. This is a pretty nice DD example. I guess I need to, yeah, I made some constants shareable in package, but this is not correct. Okay, let's check out other projects. Go Fiber, not that curious for now. Let's check out this one. Okay, that's a big project. Okay, Go Fiber has a lot of stuff. I'm just curious, how helpful is it? WS, GWT, Elastic. Elastic Beanstalk, probably. SAM container. Okay, SAM container is something I'm using right now. I'm curious how they did clean architecture, bootstrap, clean code. So what's the difference? Okay. Cloud Run. Okay, I guess we should check it out. Oh my god, they have a lot here. Okay, let's put this on cloning as well, because it's taking a while. And let me cd. Let's open Hydra and check it out. All right. Okay, let's go from CMD. Oh my goodness. They have a lot of stuff in CMD. Most of it test, create client. Okay. Root. Is root our entry point? What's in these folders? CLI client. Okay. So they have CMD prefixed stuff. They have stuff without CMD. Okay, let's try to figure it out. New root CMD. Okay, so root creates CMDs. Cobra. What is Cobra? Help config. Okay, so I assume this is configuration. Use Hydra shortcut manager. Okay. Okay. All right. So this is CLI tool, as I understand. New create CMD, Cobra command, create resource, register HTTP client flags. Alright, so this, okay. Okay. Print YAML. Alright. Add command. How do they do this? So this is CLI tool. So there's a bunch of stuff. Right. New get CMD. So where the CMDs are located? Alright, so all the CMDs are here. Okay, makes sense now. So root is the entry point, and this is all the CMDs the CLI provides, from what I understand. Get client, get, delete. Yeah. Okay. Interesting. What is serve then? New serve CMD. Okay, so this is CMD as well. Serve payment command, starting public and HTTP 2. So this is HTTP server, or, well, I assume not, since this is a, okay. I'm becoming curious, what is this stuff? This library for CLI tools, okay. And config.x, sorry, does not exist. Okay. The readme. Okay. Let's ask Claude, what the hell is this library for? Right. Okay, let's take some client. What the client, create client does. Actually, import. Maybe there is something more interesting. Update, revoke. Okay, let's have a look at create client. New client. Provide CMD. Okay, CLI client. Value. Okay. Creating auth client, getting all the values. And returning CMD. Okay. Where do we? Okay, let's look at the test, what they do. Okay, we got client secret. Okay. Let's have a look at client, create client, list, revoke. Let's have a look at update. Okay, not very fancy. Right. I don't see how this project, does it use any storage or anything? What's an internal? Internal certification. Okay, config, HTTP client. So we have HTTP client. Yeah, obviously. Kratos. Fake Kratos. Okay, indication tool. Let me read. Perfect listening, yeah. Mhm. Okay. Declan, Ivan, hey. Curious what got you on the Debizium route? Have you done much research into CDC? Well, at my job, I'm going to be working with that stuff. Actually, I am already working, but I wasn't the one who had it all the setup, right? When it came to the project, there was already CDC in place. And yeah, there was already Debizium, all the stuff. So I thought I'll do it myself to get a better understanding. And in the future, I will be working on a feature which will use, well, which will receive messages right from Kafka via Debizium, which Debizium sends. So I will build a consumer side in Golang. So I wanted to play around and get a grip on it. But overall, yeah, I've been working with it, but never created it from the scratch myself. And I've been doing it with Nest.js, not in Golang. Right. This is CLI tool. It's nice that I have it. There are a lot of cool libraries I see. I can learn. Good approach is lovely to work with. Not sure which Kafka client you're using. I'm using Confluent Inc. Yeah, there are a few. So at my job, we are using Confluent Inc. So that's what I picked. Made a project using Kafka plus Debizium. Used Frango-lib. Confluent is good. Yeah, I mean, I haven't... I know there is Serama, something like this, which is, I guess, the most popular. I'm not sure, but yeah. If I need to learn, I will learn it at some point, right? But since at my job we are using Confluent in Kafka, that's the one I'm gonna be using. Not really, just a tool. Whatever is needed, I'll learn it. Okay, let me check recipes. What does Go Fiber has? So I'm not too worried about specifics. Yeah, I've done some work with that one. Just drawback that it's using CGO bindings. Yep, that's true. It's a bit more work for DevOps. He told me about that. But I mean, for us, it's already set up. I guess it can be a performance issue, but I don't know. I've checked, asked AI if it's a performance problem. He told me, unless, right, if it's like millions of requests, it might be a problem at certain scenarios. but I haven't looked into it myself. So now I have a blind trust. And I guess it depends, right? There are lots of... Well, this is something for me to learn, actually. All right, I want to check out. They had clean architecture here. They have hexagonal, all right. Where did I say it? Oh, clean architecture, right. So we have in package repository. Interesting. So repositories are shared. And services shared. Okay. Okay, you have interface here, but at the same time you have an implementation here. Well, I guess they make it shareable, so you can use it directly in your code. Can you add link to GitHub repo? Yeah. Where is it? So this is fiber recipes, the one I have opened right now. Okay, I think I sent it to Twitch. Here it is in YouTube. I was checking Hydra. This is CLI tool. Yeah, no problem. They have a lot of stuff here. Okay, let's check out clean architecture. Book handler. So we have API. I assume this is where application layer should be, and infrastructure. Yeah, we have presenter, we have routes, handlers. So what is handler? What is presenter then? Head book. Handler controller, which creates books. Okay. Well, presenter is response. Okay. We place them in the same folder. Controller, presenter. Maybe we are doing it wrong. Response handler. Okay. Okay, this is response. And what about routes? So we have router. We have handlers. Interested in what sort of stacks people are using in prod with Go. Is Gorm quite standard? Or you're working with something that might be using queries direct, SQLC, or... Yeah, we're using SQLX. But the thing is, the service I am writing, it's like I'm going to be working on report generating service. And actually, I'm not going to be querying, not writing that many queries, right? So for us, it's just, I guess, easier to use SQLX because there are not that many queries. We're just, and this is only, I'm going to be reading from database, and most of the data already will be arriving from Kafka, which I just need to like query some additional stuff. And yeah, at least this is the project I'm going to be doing. The microservice I'm going to be building. It'll be generating like from query straight away, like Excel report, PDF report asynchronously, and then sending it via email. So I'm not even, I'm doing this with on top of read replica. Okay. long story short, I'm gonna be using SQLX. Yeah, nice, better performance either way, skipping the ORM layer. Yeah, I mean, in Nest.js we also have type ORM, and like I'm on this project already for a while. I'm working on a trucking company, logistics. I mean, probably already 3 or 4 years I'm working there. And in the beginning, right, so I was like, not the first, but well, when I joined, the project was not in production, right? It was still like MVP state. And type ORM was fine. But once you start, like you need to make some kind of bigger aggregations, queries, etc. Type ORM, we use it less and less and less, and we are just writing our own ORM because there are a lot of like hidden stuff. For simple queries like get by ID, update, insert, yeah, why not? But we have a lot of like complex queries, a lot of joins. We already just write raw queries, or we build already our own, essentially, ORM. Because you can't rely on it. It just adds too much stuff under the hood, and sometimes you can't do what you need to do. And we have like subqueries, sometimes window queries, whatever. Okay, so we have API, and in API, essentially we have controller, and we have response. I don't know if they placed in package, in the package repository and service, just so you can download this and kind of use it. But it seems like this Git repo is for examples, not for usage. So I am curious, why do they have interface in package? Okay, let's have a look at clean code. What's the difference? Main go. Let's cancel. New database. Okay. New memory database. Okay. Here we have database interface. Okay. DB implementation, load books. Okay. So this is interface, and where do we have implementations? Memory, PostgreSDB. Are you just something like max fiber, etc., and tracking any API routes as needed? Or work is mainly done from schema-driven realm of things? So max fiber, I mean, the ones I've built on the stream, I didn't use anything, right? I've built just native HTTP. I mean, I've used Max, right? Because Max is already built in. But I think I didn't use even Max that much. Let me have a look. So this is my project. What do I have here? CMD, payment service. Am I using Max? Yeah, I'm using Max. Okay. Or work is mainly done from schema-driven realm of things. What do you mean by schema-driven? You mean like from database schema, or I don't understand what you mean. Thinking in realm of planning and keeping a record of routes across all microservices. Okay, now I understand what you mean. Well, I don't know myself how to do this for big microservice. This is one of the reasons I'm checking this stuff. On most projects I work on, we'd be using something like protobufs or even just open. Yeah. I mean, you want to have documentation. So you map all service interfaces at the gateway, knowing methods that be implemented. Okay, cool. Yeah, the previous project I checked, they had the same um, GoDDD template. Well, not exactly the previous one, but one of them. I think they are doing the same thing. So but also seen projects where services just implemented routes wherever, can get messy between teams knowing what's. Yeah, exactly. That's what I've seen as well. Like, and that's why I've been checking project structures off stream, but then I thought that might be even helpful to share like what I'm checking. Because in Golang, right, in JavaScript and Nest.js, there is already like specific structure, right? Which is good and bad. Because good because everyone is doing the same, bad because you are not using your brain, right? You just you're not thinking for yourself. Already everything done for you. But in Golang, yeah, it's a blank canvas. Do whatever you want. All right, let's have a look. So they have server. Oh, right, they have generated and they have protobufs. So I think this is what you were referring to. So they have, all right, OpenAI, they have Swagger, Specs Go, and they have protobuf. Do they have internal station? Yeah, they have gRPC server and HTTP server, and just interfaces. Oh, they have interfaces for repositories. I thought they will have for server as well. For handlers, I mean, I assume they have user handler. No, it's just directly gRPC. Only repositories. But how do they switch between them? Load config. I assume from config, run, CFG. What's in config? Server. Server is there. Type of server, environment type. So how do we switch between HTTP and gRPC? Or we run just both? I assume they run both. Start service, user repo, yeah. HTTP, oh. HTTP and gRPC, they're running both. Okay. Connection cut off for a second, but yeah, get what you are saying. And agree. I love links like Golang, Runks, etc. Not just have experience, but also building side things. Not dealing with like 200 megabytes Docker image or node deployment. Yeah, like I did not realize how bad. I wouldn't say Node.js is, and I like Nest.js, right? It's cool. But right now we are building this report service. And obviously when you're generating Excel, PDF files, you're using, right, you need to create a buffer where you're going to place all of this. And for PDFs as well, we are using Chromium because we didn't find anything better. So we need to run, essentially we need to start a Chrome on the backend because it creates all the styles and generates these beautiful PDFs. Basically, according to our business requirements, we didn't find anything better. And we were doing this with Node.js. And now we're doing this with Golang, and we are running them in Lambda, right? Because so we can have like separate environment, separate resources for each report generation of PDFs. And Golang performed not just a little better, but it performed like at least 20 times better. I mean, it's obviously because, right, you just have binary straight away. If it was like C++ or whatever else, it would have done probably even better than Go, but just like when you have binary against when you have Node and you need to, right, just tremendous difference. Maybe I'll make videos about that as well, just a smaller project. and show you how we measured performance. Yeah, 100% straight up compiled, more performant, not even runtime, architecture, buffer allocation and all. Yeah. So Go performed in Lambda for like PDF generation 20 times better, at least 20 times better. For image transparent PDF gen, etc. It's lovely. Yeah. And for Lambda, this is like a double, like it's a double win, right? Because the faster it is, the less you pay. So you're getting report faster and you're paying less. All right, so this is one of the projects. Yeah, the template. Okay, let's continue looking at Go Fiber. So far, Go Fiber examples are extremely basic. I was hoping to see, yeah, how to structure projects, where to place like different types of handlers. I guess that the example for now is the best one from what I've seen. Hydra is a CLI tool, so I guess they're just a layer between other APIs, so not really applicable for me right now. Okay. App database, data source. Data sources sounds very like typo Remish, but okay. Maybe I don't know something. DB. Alright. So what do we have? We have clean code, we have DB. In DB we have just migration, okay. So essentially nothing in DB, everything is in app. We have main Go. We are creating new database, DB, close connections, new server. Okay. What is server? We are registering routes. Okay, so we have data sources and we have server. Here we have services, handlers, and domain. Okay, let's go from domain. Okay. Right. I guess it's fine, but it's very small. Are all examples like this? Also that. Let's have a look at hexagonal. Okay, let's start with domain. JSON, BSON. So we have Mongo. Oh yeah, we have Mongo. Alright, so here we have handler, product handler. I mean, we have an interface, but what's the point if we are having fiber in it? But okay. We already depend on the fiber. Kind of useless. Okay, we are implementing this interface. Alright, once again, what if you are not using fiber? Okay. Domain we've checked, repository, service, and here, I guess okay. So in the main, we have both service and repository. Okay. I guess it's fine. We usually keep repository, but I guess this hexagonal architecture. I mean, we wouldn't keep any of this in domain. This will all go into application layer. Okay, what else is here? So I guess this suggests small snippets of code. Let's have a look at WebSockets. Okay, this is just very basic. WebSocket chat. Okay, I'm curious. Contrib3 WebSocket. Okay. How many stars does it have? Ah, this is Go Fiber. Okay. So they're using Fiber for WebSockets as well. Get WebSocket new and register. We're reading message, just broadcasting all messages. Register. Okay, what if we block here? Huh? Make channel WebSocket. Register. Okay. So I did the same thing with Gorilla WebSocket. So they have one central run hub, so that they need to use mutexes. But I'll be honest with you, I haven't made this on a video about this, but on one of my streams I was testing it, and I thought this will perform better because with channels against mutexes, when you just can not send it into unregister, register, just lock here, lock, unlock, like lock here, right, and unlock, and just update map here, and well, surprise surprise, lock unlock performed better, although Go tells you, right, that you need to share memory by communicating. In other words, use channels, but for that example, actually I might have a link here, right? Sync mutex a channel, right? And somewhere here I even kept it. Share memory by communicate by sharing memory. Traditional lock and mixing package, most issues, where was it? Yeah, so when you use caches, state, right? Passing ownership, so when you're passing ownership of data, then you use channels. This would be uniform for communicating async results, right? So whenever state and essentially state, right? It's, as I understand, map, caches, map once again. So Go themselves recommend using mutexes for this kind of stuff. So essentially I was like, channels everywhere. Not really though. Well, probably next week I will start working on performance videos, and I will probably do this test and we will talk about the results. All right, so for now, Go Fiber, to be honest, I don't think anything really helpful here. I like this OriX library, although I wasn't looking for that, but I see that there is a lot of like utility tools here. Hydra is for later. Go recipes. All right, let's have a look at massive project. Grafana Loki. The examples are mainly channels for a lot of WebSocket stuff now. Have you done any distributed WebSocket stuff? I did, but with JavaScript. like passing through PubSub clients or anything for game service and the like. Yeah, I'm not sure about game service because this is something I'm curious about. How do they do this? Oh my god, Go Loki is being downloaded for like... How much stuff is here? Alright. Nevertheless, yeah, I did distributed stuff with via PubSub, and we were using Redis as initially, and then we switched to Kafka, just because to save cost, in terms of cost saving. So whenever we receive message, we publish to Kafka, then all subscribers, right, receive this message and they publish to their WebSocket, right, connections. So normally, like casinos and all, it's passed through to Kafka Rabbit. Yeah, exactly. That's what we are doing as well. I was supposed to work on that service as well, because it doesn't perform very well right now. And we were planning to rewrite it to Golang. That's why I was making some videos about WebSockets as well. But the plans changed. Now I'm going to be working on report stuff. But it's very interesting for me how to work with WebSockets. Overall, I was testing SSE. All right. Yeah, WebSockets are tricky, right? To scale them out. There are a lot of nuances, especially right when you're scaling pods. Connection draining. All right, let's go into CMD. All right, here everything is in folders. Chunks, inspect, log CLI, Loki, migrate. Okay, let's have a look at the Loki itself. WebSocket can get really interesting and can get more complex, like even adding on your own communication layers and all. Yeah, exactly. Like binary serialization instead of JSON WebSocket communication. Yes. I'm just thinking. Well, WebSockets, they always, right, send binary data. I mean, if you're sending JSON, I mean, okay, I get it. You mean if you convert to binary and then you, within your application, right, you convert to binary and then you send it over WebSockets? Yeah, Lola. Yeah, I actually tested that in one of my videos. I'm trying to remember, what did I test? Test compression, right? I didn't convert it to binary. Yeah, I was testing compression. But yeah. Can you actually do that? Well, I think, yeah, I always use library, which does the conversion to binary. Okay. Yeah, I'll need to think about it. Right, let's have a look at Grafana. So this should be interesting. Probably this should have started here. Okay, what am I? We'll check. Okay. Karma. All right. So we're getting configs, validation, reflect deep equal. So this is all just validations, validations, validations. Environment variable. Okay. All right. So here we are starting Loki. Where is it located? In package. Okay. Interesting. Okay, so they have everything in here. Okay. Guess, yeah, for them it's all shareable. Okay. Middleware. Post middleware, gRPC recovery. What is recovery? All right. Oh, whoa, whoa, whoa. That's a massive struct. Okay. I'm not gonna read it all, but team server. What is server? Server.go. It is also Grafana. Oh wow. They have a ton of stuff here. Vendor. Alright. It's in the vendor folder. Server wraps HTTP and gRPC service. Alright, yeah. So we have gRPC, we have HTTP, and we are using, well, there we go. We're using Mux. I mean, they are using Mux. We have ports. All right, internal server. We have external server, internal server, which is the same UI, etc. Okay. So server HTTP, we are creating config. Tenant we add in limits. Tenant limit handlers. Extract tenant ID from request. Okay. Nice. Not sure if you looked at gRPC much, but there are levels where you can map the gRPC method to gRPC routes. Well, yeah, I assume. But like, why? What's the benefit of doing this? Not just gRPC web and all, and Voi has a built-in filter and stuff to support it, plus a library called gRPC gateway, which is pretty cool. Looks like they might be doing the mapping manually in Loki. Where's building? The benefit, I mean, you can have all services using gRPC, then some externally facing methods as HTTP with internal methods in the faster binary serialized gRPC. Okay. Yeah, so for internal you use gRPC, for external HTTP, right? Yeah, I was thinking about like... Okay. So what does it do is it gives you mapping. The levels you can map the gRPC methods to HTTP routes. So that's what I'm a bit confused. So how do we map gRPC methods? Yeah, I understood what you mean. Okay. Okay, this is cool. That's cool, right? So you essentially you write less code, right? You have one place, right? Central place. So gRPC, like protobuf, is your source of truth, sort of, right? And everything goes from there. So HTTP depends, right, on gRPC. And if you want to add something just purely for HTTP, anyways, you add it in protobuf, as I understand. All right, let's have a look. So we are binding endpoints, nothing special here. We have HTTP gRPC server. Here is where gRPC, yep, we have gRPC here as well. Okay, let's return. Module manager. Okay, this is what I'm curious about. How do they manage a ton of dependencies, a ton of routes, map string module, dependencies, list of modules. Okay. Init function, user visible. Okay, this is just some booleans. So we have a list of dependencies. So essentially we are creating a dependency tree. All right. Init module services. We are providing config, service map. Okay. Init map, init module. Okay, this is interesting. Order depths. So we ordered them, we appended them, then we are ranging over dependencies. If it already initialized, right, we are skipping it. Otherwise, mod init function, and we are triggering init function. I'm curious what's this is just, yeah, interface. If s is not nil, we pass services map isn't compiled, but the time services struck will be fully built, so there is no need to extra synchronization. Sorry, my signal isn't the best at the moment, but yeah, sort of. You can map JSON to the protobufs, which adjust from the protobuf schema. This itself enforces forward backward. Yeah, that's what I thought. What by schema you can change in a message and the likes. Okay, yeah, that's cool. So gRPC is your, protobuf is your source of truth, right? You build protobuf, you define types in protobuf, and then they're being mapped into everything, as I understand. Yeah, this is cool. So you have single source of truth. Everyone knows where to look. Yeah, sort of all schema driven there on the API side. Yeah, okay, makes sense. Can actually use a shared protobuf repo for all microservices across all teams and use your bits. Yeah, this is something we are actually debating right now. Should we have like a one giant monorepo or separate repos, and then we need to share a lot of stuff? So we are leaning towards having a monorepo. Seems like it's easier to manage everything. For us developers, it's kind of okay, but for DevOps, said for him it's like the time difference is quite big. For him, it's easier to manage monorepo, build all the pipelines in one place. Done both approaches, but normally lean on the monorepo side for schemas and stuff, which everyone can update. Yeah, exactly. Because otherwise you need to write tests, you need to write how do you make guarantee that you start your... The biggest problem, right? You are developing something and someone else changed something and you have no idea about that. With monorepo, you straight away know. Then you can have individual repos for the services which base off monorepo. Or API code gen or pulling migrations, whatever. Yeah, exactly. I agree. Yeah, monorepo seems easy. And lots of repos just makes it makes deployments much harder. I mean, this is what DevOps told us. I didn't look into it, but like for us developers, even for us for developers, right? The biggest problem, once again, yeah, someone is developing something in another repo schema, something changed, and unless you tell another team, they need to add, right, a lot of layers of protection. And we already had an issue with that because we have like downstream services. We have like our own tracking service and we're making some updates, like we are inserting some data into database. And once again, we're using Debezium and we have like downstream payment service. And not knowingly, which sent some stuff and their service started to fail because they didn't have validations in place for that scenario, but it was a bit tricky, but nevertheless. And although we are all the time on the same meetings, still we ran into this problem. Okay, so I like how they're initializing modules. I want to see what is init module functions. Okay, so this is auto-generated. It's auto-generated. Okay. With your Kafka, you're using like Confluent Schema Store or something, or just sort of setting just on override hover or something. Yeah, right now we are sending just whatever, and we have tests on both sides. So our like downstream service, well, actually how it works, so this specific downstream service, they have a part of their code in our code base. So we are not streaming directly our entity updates. They have essentially outbox. So they added their methods all over our code and they are mapping updates and they are making their own like outbox table, and then it's being streamed to them. So they need to constantly, they have tests, but yeah, something happened. So we added some new columns and they were not mapping them. And essentially they were not receiving all the data. That was the problem. So they have like, right, so there is like our service and their service. And within our service, right, we're making some kind of DB changes, like our service. We're making some kind of, I don't know, like add entity. And they're have a part of their code. They create outbox. And they need to map every field they need, they're curious about. And then this outbox sends to, here is the Visium. And then, right, it's being sent to them. This is payment. Something like this. So here in the mapping part, we added some columns. They just didn't store them into their outbox entity database and no database table. And they just never received it, although they have tests, but yeah, they didn't have tests for scenarios when we're adding something new, this particular, and it caused some issues. So this is one of the examples already happened. Okay, so you're manually using the Visium for the outbox side of things, not as much CDC or whatever, but yeah, current message format makes sense. I mean, yeah, regarding message format, we will move into it to Avrom, but for now, just all, you know, depends on business side. We have like gigantic backlog of improvements. And obviously it's always like business side they will ask, why should I care about this? Does it impact performance? Does it impact something? And these kind of things, they're on the, not really, right? Although they impact performance, but it's not the performance the users will see. And so it really doesn't really matter, right? If you will save something like later on, a second later. At least at the current stage, it's not a priority. Maybe it will become. Here's what is init function in memory go. Okay. So they have I guess this is the one. Oh, this interface. Is this the place? Exec go get init function, kernel init function. Okay, so what is in kernels? Okay. Alright, I will need to look into this more. How they... This is interesting for me, how they initialize all the modules. Down request, okay. Atomic, okay. HTTP, then gRPC. My coffee is already cold. Oh yeah, it's been more than an hour. Okay, so far I really like this project. I think I can learn a lot here. Okay. Implementation, any. We are providing the entire thing, new health check with manager, SM, service manager. This is interesting that they are using like this with manager. We are providing lots of checks, and with manager provides check, but where is the manager? So we have statuses, and what do we do with statuses? Okay. So manager has all the states, and we are doing validation here. Service but state. Okay, there we go. The locking of the map. State, integer, iota. Okay, they even have a diagram. Nice. This is a good documentation. Okay. Okay, we are binding config endpoints. Haven't we done that before? We need module services. Need module. Okay, maybe not. Right. So we are registering gRPC, health check, HTTP routes. Logbook. Game. Any saves first, stop entire locking. Stop async. What does it do? It's an interface. Okay. So as I understand, they're using context, all of that. I'm just curious how they send termination to all their services. Ring client. Interesting. So ring. Ring is a service that maintains in-memory copy of a ring and watches for changes. Supports ring. So this is a ring buffer or? Only in the ring. Game. Alright, so we have basic service and it has the stop async implementation. So we can get its state. Just lock. So we are closing the channels. Notify listeners. We're providing function. L terminated. New. What is new? Switch state. From to state function. Okay. Okay, so new state. So we are switching state from new to terminated, closing channels, and notifying listeners. L terminated new. Okay, so we have a list of listeners and we are just sending to their channel and closing. Okay. Let's go back to Loki. Hmm. Each listener has its own go routine. Okay. See, they like using this button when they provide function as an argument. Yeah. It's very quite common in Golang. I guess it's probably not that common in JavaScript and common in other places. Okay. Once again, how do we use we provide manager listener, healthy stopped failure, healthy stopped failure. So all of this is a function, right? Func base manager listener. All right. So this is a ton of functions. And this is a loop where we something there. Loop for exit, shutdown requested, store, true. Okay. Yeah, a lot of validations, a lot of closing procedures, which is very interesting. All right. The 90 minutes are done. Okay, guys. I really like this Loki project. I'll probably look into it more. There is so many things which I don't understand and I would like to. And I can see that, yeah, there is a lot of things I can learn from. Okay, overall, what do we have here? We have Loki. So we are in package Loki. Yeah, obviously they have a lot of stuff, as I understand, for like Ring. It was for deployment. Fury tree. Yeah, I need to go through all of in a more focused fashion. Look into this. So what do they have? They have vendor, tools, production, okay, Terraform, Helm, Docker, all right. Package. What do they have, for example, in Kafka? Kafka v2, consumer. there we go. They're using friends go. Declan, if you're still here. Yeah, so as you can see, pretty nice native Go. Yeah. Okay, the methods are, I can see, a bit different, obviously. But overall, offset.go, new committer, commit, add offset, commit offsets. Okay, I should check out when they are committing offsets. Offset reader, topic, logger. Okay, so I think they're doing something similar to what I was doing on my streams. Obviously, more logic because they have more logic overall. Last committed offset, code the partition, resume offset, next assume. Oh, I think they're using Kafka transactions. Alrighty, guys. I'm gonna be wrapping it up because I need to do other stuff already, unfortunately. But yeah, I need to look into this. I like this Loki project. I know I said it multiple times already. Anyways, thanks everyone for watching. Thank you for chatting and giving me ideas. I appreciate it. Okay, I'm gonna be wrapping it up. Once again, thanks for watching. See you next time.